In terms of probability, when you perform any experiment, that is called as a trial, and the outcome or output of that particular experiment is called as an event or cases. When we say that for a particular experiment you are having all possible outcomes, then these all possible outcomes are collectively called as a sample space or exhaustive event. That is also denoted with set S. Let's take example where we are tossing 3 coins. When you will toss one coin, you will get the output that on the top of that coin you can see that it is having head or tail. But if you will toss 3 coins, then in that case you can see multiple possibilities. You can see head on the first coin, tail on the second coin, on the third coin you can see tail also. So in this way there are total 8 possible ways or outcomes you can see on the top of your coins. So the sample space will be all of these 8 possible outcomes. Favorable event. Let's perform this experiment. You are tossing 3 coins, and additionally I say that ki at least you should have 2 head on the top of your coins. In that case your outcome will become, among all of this you will just need to pick only the possibilities where you are having at least 2 heads. So the possibility can be 3 heads, 2 heads. So these are all possible solution for this particular special case. Now this is called as your favorable event. If 2 events are incompatible, then that they are called as a mutually exclusive event. And for performing an experiment, if 2 events are having this same possible outcomes, in that case we say that they are equally likely event. Let's take example where you are tossing a single coin. Then when you will toss a single coin, you can have chance that you can see head on the top or tail on the top. The formula for probability is that it is denoted by P of E, where P stands for probability of event, which is equal to number of favorable event divided by sample space. Now if we try to represent this in terms of some formula, we can say this probability is success probability for that particular event. What are the chances you are getting? That probability will be success, and failure will be if you are not able to see that particular event, then that will be failure probability. So success probability is probability of occurrence of an event, and failure probability is probability of non-occurrence of an event. Both this success and failure probability combinedly forms a probability whose value is 1. So V plus Q equal to 1. And if we say that you have performed some experiment, but for particular event you are not getting any output, so then that event is called as an impossible event whose probability is 0. 2 events can be said as mutually exclusive when union of these 2 events, for example here, their union is just addition of separate of these events, probability of first event and plus probability of second event. Two events are independent when their intersection, the common portion between the 2 events, is the product of their 2 probabilities. Let's take example for probability. 2 cards are drawn at random from an ordinary deck of 52 cards. Find probability that both are spade, one is spade and other is heart. Now initially what we are just trying to do, we are just trying to pick only the 2 cards from the deck of 52 cards. In a deck of 52 cards we have 4 suit, each suit have 13 cards. Now we just have to take out 2 cards initially, then this will be our sample space. We have not added any additional sentence in this, we are just simply taking out some cards. So this will be my sample space. So possible ways to select 2 cards from 52 pack, that will be 52 combination 2. Now this is my sample space, and additionally what is given that you have to ensure that both are spade. Now my cards will be spade only if I am just taking out both the cards from the spade suit only. So the favorable event will be this. Now this is the favorable event. Now for this possible selection will be 2 spades card can be selected in. Now there are total 13 cards of spade, so 13 combination 2 ways are there to select 2 spade card from the total 13 cards of your spade. So the probability for this will be favorable event divided by sample space, which is 13C2 divided by 52C2. When you will solve this, you will get the value that is 0.059. The next is that when you are taking two cards from the pack, you have to make sure that that one is spade and the other card is heart. Now in this, you will be sure when your one card is spade, when you are taking from all of the spade cards, you are just taking one card, and from all of the suit of heart card, you are just taking one card. So in that case, you will be sure that your one card is always be spade and other card is always be heart. So the possible ways to select one card which is spade and other card which is heart is 13C1 into 13C1. Why I have multiplied this? Because you have to get this two card. You don't have to just pick one card. It's and there, so you have to multiply it. So favorable event is this. So favorable possibility is this. So the probability for this will be total possible selection for your favorable event divided by your sample space. So if you solve this, we will get the answer, that is 0.12. Let's take another example where we just want to take probability in much more different ways. Now question is, what is chance that a leap year selected at random will contain 53 Sundays? We have to find out in what condition you will get 53 Sundays from a leap year, and what is the probability of getting that Sundays, 53 Sundays. Now we know that in a leap year we have 366 days. If we just try to convert it into weeks. Now in total week we are having 7 days. Among all of the days, one day is always a Sunday. Means if we'll go by calculation of weeks, we will surely get one Sunday in that. So the total weeks from 360, total weeks in a 366 days will be 366 modulus 7, which will give us the value, that is 52 is quotient and 2 is remainder. So in this 52 Sundays are for sure, they are there, 52 Sundays are there. So what we have to do, the main thing which rely on the main thing which is the answer, which rely on this 2 remaining days. So whatever selection you are having for these 2 remaining days, they will going to give us the answer for this particular question, because 52 Sundays are there. So our whole answer will depend on these 2 remaining days. Now as this is a kind of calendar days, so always the days of your calendar are consecutive days, 2 days which are coming one after other. So all the possibilities for coming for 2 days from your calendar days are Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. Now these are all possible 7 possibilities where you are having 2 consecutive days. Now we just have to look where we are having Sunday in all of this possibility. Now at this place we are having Sunday. In this selection we are having Sunday. Now these are only 2 selection among 7 selection possible ways. So the probability for selecting 2 days will be, which are Sunday, will be count of count of ways where there is Sunday is available divided by total count of 2 days. So it is 2 by 7. So answer for this is 2 by 7. Chance is there that you are having total 53 Sundays. There is a probability of 2 by 7 where you can be sure that you are having 53 Sundays in a leap year. Next question is that a bag contains 3 red, 6 white, 7 blue balls. What is probability that 2 balls drawn are white and blue? Now in this question we are given with a bag, and in that bag 3 colors balls are there. Next is that what we are doing, we are just taking out 2 balls at a random, and then we are specifying that one ball is white and then other ball is blue. So simple thing which we are doing for the first time is taking out 2 balls. So all possible ways to taking out 2 balls from a bag will be your sample space. So first of all we have to calculate how many total balls are there of different colors. So total balls in the bag are 3 plus 6 plus 7, which is 16. The sample space is taking out 2 balls from your bag. Possible ways for that is 16C2, so which is 120. Now further what we have to do, we have to calculate probability that 2 balls drawn at random or two balls drawn from a bag are white and blue. So my one ball is white and other ball is blue. So when I will get one ball is always white when I'm just taking one ball from the white collection of balls, and I'm just taking one ball from the blue collection ball. In that case, I will get that one ball is always white and other ball is always blue. So total possible way to select two balls such that one is white and other is blue will be 6c1 7c1 multiplication of this, that is 42, and the probability for this is your favorable event is where you are getting these two balls, one is of white color and blue color, that is 42, divided by just taking out two balls from a bag, that is 120. So this is my probability for finding that two balls drawn at a random are white and blue. Conditional probability: when you are performing any kind of event and the occurrence of another event depend on previous event which is earlier happened, so then that is called as a conditional probability. Now in this conditional probability, for example, if you are having probability of b by a which is equal to probability of a intersection b divided by probability of a. Now this is a formula for basic conditional probability. What is the meaning of that? This is like probability of occurrence of your event b such that under the condition that event a is already occurred. Now what is the probability for this? Now this is probability of both of this event divided by probability of first event. And suppose if we are just having only one bag or only one particular pack, in that case this formula is applicable. But if you are having such kind of things where you are having multiple bags or multiple suit of packs, in this case you will use the Bayes theorem, which is this. So we will later on cover this. Let's take example for the basic conditional probability. Find probability of drawing a card of spade on each of two consecutive draws from a well shuffled pack of card. The meaning of this is that we have to find probability of two events without replacement of first card. Now to calculate what is the probability of both of this event, which is probability of A intersection B, we first of all we have to calculate the individual probability of this event. Now first event is that you are just taking out one spade card from a pack. The probability of taking out first card from a pack of your whole suit, which is a spade, is 13 divided by 52. There are total 13 spade cards. From that you are taking out one card. So that is favorable event divided by how many ways are there, how many possible chances are there to take out one card from your 52 pack. So you can have 52 chances. So it is 13 by 52. Next is that on the next round, two consecutive draws from a well shuffled pack of card without replacement of first card. Means you have taken out one card from a 52 card, but you are not keeping that card in that pack again. So you will be having only 51 cards in your suit of cards. So one card is taken out from that suit. So in that case, what you will be having probability? So probability of taking out second card such that first card is already taken, which is equal to probability of b by a, will be, now we have taken one card from a spade suit, so we will be having 13 minus 1 cards remaining in our spade suit, so that will be 12 packs, 12 cards will be there in your spade category. So you will be having 12 divided by 51. Now among all of the suit there are 52 cards are there. So from a 52 card, one card is taken away from spade category, so you will be having 51 cards. So you will be having probability of 12 by 51. So this is the probability of my second event. Now according to conditional theorem, we know that probability of b by a is equal to probability of both the events divided by probability of first event. Now this will be probability of both the event will be probability of second event such that first event is occurred into probability of A. Now if we'll put all of these values in this formula, we'll get the answer, that is 0.059 is probability that in ways we are taking out the two consecutive cards from the spade without replacement of the first card. Next question is that now this is the conditional probability, but in this case what we are doing, we are considering that your packs are different. on each individual this pack or suit we are having this conditional probability. Now in this case we go for the Bayes theorem. Let's understand what is the question. Question is that content of urn 1, 2 and 3 balls are given. Now what we have to do, one urn is chosen at random and two balls are drawn. They happen to be white and red. What is the probability that they come from urn 1, urn 2 and urn 3? The meaning of this question is that simply first of all we are just taking out from among three urns we are selecting one urn is chosen. From that urn we are taking out two balls. This is a general case or this is the sample case, you are just taking out two balls. Next special condition given is that happen to be white and red. Now special case is that when you are taking out two balls you are making surety that one ball is of white color and other ball is of red color. And after performing all of this you have to find the probability that whatever balls you have taken out, what is the chance that they are coming from first on, second on or third on. So this is what we have to find out. This is the sequence of flow of your question. Now first of all we will find out what is the probability of each urn. So as there are only three urns, among three urns I can select one urn, first urn in 1 by 3 ways, this urn in 1 by 3 ways. So in total for each of this urn, the probability of urn 1 is equal to probability of urn 2 is equal to probability of urn 3 is 1 by 3. Next is that we are selecting two balls from each urn and we are just making surety that one is of white color and other is of red color. Now just understand how we will select this for first urn. In first urn we are having one white ball, two black balls, three red balls. There are total 6 balls. We have to take one white ball and one red ball. Now the possible ways in which we can select one white ball and one red ball is 1 combination 1 for white ball into 3 combination 1 for red ball divided by, now as we are finding out the probability for the first urn, so this is a favorable event divided by general case where you are just taking out the two cards. So this is the sample space. Now sample space is just you don't know what color you are having for the ball, you are just taking out two balls from this urn. So possible ways to select two balls from this urn is, there are total 6 balls, so 6 combination 2 ways are there. So the probability for taking out two cards from the first urn where your one ball is of white color and other is of red color will be this, and when we will calculate this we will get the value that is 1 by 5. In the same way we have to perform the same calculation for urn 2. We will get the probability that probability of event that A is the event of taking out two balls, one is of white color and other is of red color from urn 2 will be 2C1 into 1C1 divided by 2 plus 1 plus 1 that is 4, 4C2 which is 1 by 3. Probability of event A divided by urn 3, that is probability of event A for urn 3 will be 4C1 into 3C1 divided by 4 plus 5 plus 3 is 12. So 12C2 which is equal to 2 by 11. Now we have just simply calculated how many ways or what is the probability of just taking out two balls from each of these urns. Now next thing is that we have to find out whatever balls you have taken out, what is the probability that that ball is coming from this urn or this urn or this urn. Means we have to individually find out the probability for each of these urns. Now the probability for this urn, first urn will be, now what is the probability for first this urn that whatever event, whatever balls you have selected, now probability that you are having that balls are coming from first urn such that two balls are already taken out. Now this probability is just perform multiplication of probability of this probability of urn 1 into just reverse this, that will be probability of event A that such that that is taken out from first urn. In the same way, just perform this formula for all of these urns and perform summation. Probability of urn 1 into probability of A by U1 plus probability of urn 2 into probability of A by U2 plus for this urn. Now we have already calculated all of these values. So probability of urn 1 in the previous slide, that is 1 by 3. For all of this urn, probability is 1 by 3. And probability of event taking out two ball from first urn, one is white of color and other is of red color, that is 1 by 3. Just keep this value over this place and perform all of this. Just keep all of these remaining values. We will get the value that is 33 by 118. So there is 33 divided by 118 possibility are there, such that you are whatever balls you have taken out, they are coming from on 1. In the same way, we have to perform for on 2 and on 3. So the chance for on 2 is 55 divided by 118, and the probability for whatever balls you have selected, they are coming from on 3, that is 30 by 118. Let's understand what is binomial probability. We have already discussed binomial theorem. Binomial theorem is just kind of this particular way where you are just performing, you are getting the equation for this formula. That is a plus suppose p plus q or q plus p raised to n will be summation of your r equal to 0 to n combination r into first term raised to n minus r into second term raised to r. So this is the formula for your binomial theorem. And now what we have to do, instead of splitting this term for particular equation, we are actually keeping, instead of q and p, we are actually keeping the values of probability, and n is our how many times you are performing that experiment. So the probability of binomial experiment, the binomial experiment where you are just performing that experiment n times, and p is the probability of getting success. Now in that case, your probability will be this. And based on this, we are having different formula. The mean or expected number of success is number of trials into number of success. Variance is number of how many times you perform that particular experiment, that is number of trials into success probability into failure probability, and the standard deviation is just the square root of your variance. Let's understand some of the example. A fair coin is thrown 10 times, so 10 times will be the value of my n. Find probability of getting exactly 6 head. Now here we have to focus on the head, so head will be my probability of success, and next is that we have to find probability of getting at least 6 head. So in the sequence we will find out what is the value of n, p, q. So n is 10, how many times you are performing that experiment. P is probability of getting head, that is getting success is p, and q will be probability of getting failure. So when you will be having failure, when instead of getting head you are getting tail, and you are just throwing one coin for multiple times. So when you throw one coin, you will have two chances, you can get either head or tail. Probability of getting head is 1 by 2 and probability of getting tail is 1 by 2. So probability small p is 1 by 2, small q is 1 by 2. So getting exactly 6 head, in that case we just have to find out what is the value of p of rth term where r is 6. So that will be NCR p to the power r q to the power n minus r. So we just have to keep the values of all of this. P is 1 by 2, q is 1 by 2, r is 6, n is 10 in this formula. And then that will become 10 combination 6 into success probability is 1 by 2 raised to 6. Failure probability is 1 by 2 raised to n minus r, that is 10 minus 6. When we will solve this, we will get the answer, that is 0.205. Next is that we have to find probability of getting at least 6 head. Now here we just have to start from when we are getting 6 head and till how many times you have thrown the coin. So the probability will be probability when you are getting 6 head plus probability when you are getting 7 head plus probability when you are getting 8 head till your how many times, what is the last time of getting, what is the high time of getting your head in this particular sequence. So that is when you will get that head 10 times. So in the same way, whatever we perform for p equal to 6, that p equal to probability of r equal to 6, we have to just keep this formula for all of these r values, where p of r is 6, p of r is 7, p of r is 8, r is 9 and 10. Perform all of this, we will get the final answer, that is 0.317.